Bismillahirrahmanirrahim. Assalamualaikum and good day to Prof and my fellow friends. So today we are from Group 4. We'll present on the acetic acid production. My name is Imanina Nazifa, together with Aimi Diyana, Siti Norhana, Siti Norsuriani, and Xie Hao Xi. The content that we will present are introduction, producer, product, process, mode of bioreactor, and product recovery. So firstly, let us look at the introduction to acetic acid. Acetic acid is also known as ethanoic acid, ethylic acid, vinegar acid, and methane carboxylic acid. It has the chemical formula of CH3COOH. And of course, acetic acid is a byproduct of fermentation. After formic acid, acetic acid is the second simplest carboxylic acid. The acetyl group, which is derived from acetic acid, is fundamental to the biochemistry of virtually all life forms. Other than that, the acetic acid fermentation is an extremely exothermic process, enhancing the temperature to 50 degrees Celsius. Now I would like to present on the producer of acetic acid. The acetic acid is produced naturally when excreted by certain bacteria such as Acetobacter genus and Clostridium acetobutylsum. These bacteria are found in foodstuff, water, and soil. And acetic acid is also produced naturally when fruits and other food spoils. In industrial, acetic acid is produced both synthetically by bacterial fermentation and by bacterial fermentation. Approximately 75% of acetic acid is used in the chemical industry made by the carbonylation of methanol, and the biologic method accounts for only 10% of world production. But it is important for the manufacture of vinegar because many food purity laws require vinegar used in food to be of biological origin. Lastly, the most acetic acid is made by methanol carbonylation, where methanol and carbon monoxide react to produce acetic acid. The compound is miscible with ethanol, ethyl ether, acetone, and benzene, and it is soluble in carbon tetrachloride and carbon disulfide. So that's all from me. I will pass to my next presenter. Thank you.
For the product of acetic acid, it is a product, meaning by chemical routine involving homogeneity and heterogeneity catalyst methods. Next, I would like to introduce three different processes for it. The carbonation process is the most commonly used commercial routine for acetic acid synthesis. In the presence of Rm basic catalyst, it is react in the lipid phase at 150 to 200 Celsius and 30 to 50 bar to produce a selectivity of 95% acetic acid and 5% byproduct. The use of the iridium catalyst increased the overall rate of the reaction. Oxidation is the main process for the synthesis of the acetic acid, in which acetaldehyde is the first prepared by the oxidation of acetylene with palladium and copper chloride, and then further oxidized to the acetic acid. Hydrocarbon extract from oil feedstocks, for example, butane, is used to produce acetic acid. Use cobalt to catalyze. The reaction takes place at a relatively high temperature and pressure, mainly stable for the production of the food-grade acetic acid, named is vinegar. The process involves the use of renewable carbon resources such as apple, grapes, starchy, beer, and wine. The fermentation process is delivered into two main steps: yeast treatment following the by acetic acid by bacterial treatment. Commercial product of a vinegar is accomplished by oxidative fermentation use AAB. For example, the Europe is used to produce high concentration of 10% acetic acid. It's derived from the French word that it is well established and traditional, which is preferred for low volume production of acetic acid. One example of this method it is the traditional vinegar from Spanish and Greek, even Italian. For this method, the purpose of why people develop it is that it is used to overcome the slow rate of acidification in the last method and improve the acetic acid material and the substrate interaction. For this method, the continuous submerge process, this is a modern fermentation technique that it allows to produce vinegar in the mass, and the mass wellness be used to obtain the highest along with a fast rate of the oxidation as compared to previous two methods, and it is 3 times faster than the Wohlen methods of higher efficiency for production of acetic acid.
Alright, thank you Irina for the explanation of the product. Now we continue the process of acetic acid production. Do you guys know how acetic acid is produced? The production of acetic acid can be carried out by 2 ways, either in aerobic or anaerobic fermentation. The anaerobic process is one-stage process carried out by the Clostridium, while the aerobic fermentation is 2-stage process. The first stage process in aerobic fermentation is that when the glucose is converted into ethanol by Saccharomyces cerevisiae. The second stage is where the ethanol is converted into acetic acid by Acetobacter aceti. This fermentation is usually initiated by the yeast, which is Saccharomyces cerevisiae, which it breaks down the glucose into ethyl alcohol with the liberation of carbon dioxide gas. Following on from the yeast, the Acetobacter aceti oxidizes the alcohol into acetic acid and water. As you can see here, these are the chemical equations on the yeast reaction to produce ethanol and the reaction of Acetobacter aceti in converting the ethanol by the use of oxygen into acetic acid and water. Next, the Acetobacter aceti is dependent upon the yeast to produce an easily oxidizable substance, which is ethyl alcohol. It is not possible to produce the vinegar by the action of one type of microorganisms alone. In order to produce acetic acid, ethanol fermentation is essential and need to have a sugar concentration of around 20%, and also the pH and the temperature should be maintained at around 5 and 32 degrees Celsius respectively. Therefore, for a good acetic acid fermentation, it is required to have an alcohol concentration of 10 to 13%. If the alcohol content is much higher, which is above 13%, the alcohol is incompletely oxidized to acetic acid. But if it's lower than 13%, there is a loss of vinegar because the esters and the acetic acid are oxidized. In addition to acetic acid, other organic acids are formed during the fermentation, which becomes the esterified and contributes to the characteristic, which is odor, flavor, and color of the vinegar. The pH and the temperature should be maintained around 4.5 and 30 degrees Celsius respectively. In general, the yield of acetic acid from glucose is approximately 60%. That is, 3 parts of glucose can yield into 2 parts of acetic acid. And lastly, for the analysis of ethanol and acetic acid production, gas chromatography and the high-performance liquid chromatography methods are used. That's all from me. I pass to Norsuriani for the mode of bioreactor operation.
Next is the mode of bioreactor operation. For acetic acid production, the mode of bioreactor operation can be in batch, fat batch, and continuous fermentation. But today, I'm going to explain more about the fat batch fermentation. Fat batch fermentation is a liquid fermentation process in which one or more nutrients are fed to the fermenter during cultivation, but no removal of culture until end of process. This type of fermentation is a partly open system, and concentration of nutrients fed into the culture liquid can be controlled by changing the feed rate. For production of acetic acid, a small amount of ethanol-rich medium was fed to the culture of Acetobacter acetyl intermittently to maintain an appropriate concentration of ethanol to avoid growth inhibition of Acetobacter acetyl. Thus, the user can either set the feed rate manually at any time or adding the ethanol-rich medium when specific conditions are met, such as when the desired concentration of acetic acid is met or when the nutrients was depleted. Next, by controlling the addition of ethanol into the fermenter properly, lag time can be shortened and the growth inhibition of the Acetobacter acetyl by ethanol can be reduced. Growth of Acetobacter acetyl also inhibited by the accumulation of acetic acid. It happens when the concentration of acetic acid is higher than about 40 grams per liter. The growth inhibition of Acetobacter acetyl by high concentration of acetic acid can be avoided by cell recycling using a membrane filter. Thus, the environmental condition of the Acetobacter acetyl can be optimized in line with their phases of growth. Fat batch fermentation allows the extension of the operating time, which leads to a higher Acetobacter acetyl concentration and thereby improves productivity. Lastly, the fermentation process will stop when the volume of the fermenter reaches maximum.
Assalamualaikum warahmatullahi wabarakatuh. I'm Aimi and I will continue the presentation by explaining to you what process that we can use to recover our product, which are acetic acid. The objective of this product recovery is firstly to increase the rate of product inhibited fermentations. Secondly, we want to reduce the cost of wastewater treatment and also to minimize products degradation. We have two types of ways to recover the acetic acid, which are liquid-liquid extraction or LLE and extraction distillation that we call as azeotropic distillation. If you all can see, I already compared these two types of ways to recover the acetic acids, which both of types have the same function like to separate the acid and water. So for the azeotropic distillation, this method is used only for 50% until 70% of the acetic acid. Meanwhile, if our acetic acid have weight concentration below 40%, the most appropriate method is liquid-liquid extraction. So firstly, let me explain about the azeotropic distillation method. So this method can separate the acetic acid and water so that acetic acid can be recycled back to the reactor while the water generated by the reaction is sent back to the wastewater treatment facility for safe disposal. So for your information, the normal distillation of acetic acid is not very efficient due to the close boiling characteristic of the acetic acid and water system. So by adding the third component like a selective alkyl acetate such as isobutyl acetate and normal butyl acetate as an entrainers, it will form a low boiling point azeotrope with water and therefore improve a relative volatility for separation between acetic acid and alkyl acetate. However, this method is less applied due to the high energy and their high cost. So the next method is liquid-liquid extraction or LLE. It is used to separate two miscible liquids using various solvents that preferentially dissolve one of them and thus allowing the other component to live at the top of the extraction column. But after the extraction is complete, a complicated series of distillation steps need to be done to recover the acid and to recirculate back the solvent to the extraction column. So in this method, acetic acid is extracted from water by a suitable solvent in order to obtain pure acetic acid such as acetates and ketones. Actually, this extracting solvent for any liquid extraction are mainly depends on its extractive capacity and equilibrium characteristic from its stability, favorable density, viscosity, tension properties, and the differences between solute and solvent. And for your information, if we compare to the isotropic method just now, this LLE method occur in low temperature for 25 degrees Celsius, and it is a low cost process. So you can see between these two figures where this isotropic method is a bit complicated than the LLE method. So we have come to the last part of the presentation where I will summarize all my friends' points just now. We know that acetic acid, also called as ethanoic acid, that produced via fermentation. Its pathway is a conversion of glucose to ethanol and ethanol to acetic acid. So the mode of the bioreactor of this fermentation process is a fat batch fermentation. And lastly, we also know that the separation of product can be occur in two methods followed by each requirements, which are liquid-liquid extraction and isotropic distillation. So I think that's all from our group. Thank you.